How does synaptic pruning shape a child's brain development? Have you ever wondered how a child's brain becomes so adept at learning and adapting? One key process involved is synaptic pruning. This natural phenomenon plays a significant role in shaping a child's brain development. Synaptic pruning is where the brain gets rid of extra neurons and connections that are not needed. This process kicks off around the age of 2 and continues into adolescence and early adulthood. During early growth, infants have an abundance of synapses, sometimes more than double the amount found in adults. Synaptic pruning helps reduce this excess by about 50% between the ages of 2 and 10. So, how does this impact brain development? Well, synaptic pruning strengthens important neural pathways while removing weaker or unused connections. This selective elimination allows the brain to specialize and adapt based on experiences and the environment. For instance, synapses that are used frequently for skills or senses are preserved and reinforced. In contrast, those that are less utilized are pruned away. This makes the brain more efficient in processing information, learning, and memory. Interestingly, synaptic pruning does not happen uniformly across the brain. In the visual cortex, pruning occurs rapidly during early childhood. However, in the prefrontal cortex, which handles complex tasks like decision-making and personality, pruning continues into the late teens and 20s. This extended period of pruning supports the development of higher cognitive functions. From the standpoint of infant brain growth and early childhood neurodevelopment, synaptic pruning is essential. It allows the brain to adapt to its surroundings by sculpting the neural circuits that support learning behavior and cognitive abilities. This is why young children can learn languages and new skills so quickly. Their brains initially form many connections, providing flexibility, and then pruning refines these connections for optimal function. However, it is important to note that abnormal synaptic pruning can negatively affect development. If pruning is insufficient, it may be linked to conditions like autism spectrum disorder, attention deficit hyperactivity disorder, and schizophrenia. This can lead to cognitive, emotional, and behavioral challenges. Conversely, excessive pruning can also impair cognitive abilities and emotional regulation. Therefore, a healthy environment and experiences during early childhood are vital. They support balanced synaptic pruning and promote healthy brain development. Synaptic pruning shapes a child's brain development by refining neural connections, improving efficiency, and adapting the brain's architecture based on experience. This process is a fundamental aspect of neurodevelopment from infancy through adolescence.